Again, when you do your triangle, remember to do a determinant. You need a square so that you're going to fill that column with ones. And the negative is there so that if your determinant is negative, you use the negative sign because your area always has to be positive. Okay? Stop me if you have any questions. I know these are kind of redundant just doing them, but get used to filling those with a 1 on that because it's not a square. If you leave it like this, if you leave it 27 over 8, whichever way you left it, as long as it terminates or is a reduced fraction. Oh, it's 30, sorry, 30, is that 33 over 8? 33 over 8, not 3 and 3/8, sorry. 33 over 8. Okay. Again, this guy, they work just as well when they have fractions in them. We don't have any units in these because really there's not really no units other than just your coordinate grid. Okay, now we get to the good stuff. So using your determinant to solve your system. Find your coefficient matrix. And for you guys that weren't here yesterday, coefficient, constant. Take the determinant, and these should be a straight. Take the determinant of your coefficient. That's the big determinant. This guy. And replace this column with the x and find the x. Find the x determinant. Set it up so that you make a ratio, solve for x. Then do the same with the y. Take this column, put it in the second one, where the y is. Find the determinant, find the y. Questions? Were you able to do this? Everybody able to do this? Okay. I get it that RREF is the easiest way, but it's good to know other ways. They're useful in other ways. This one had a determinant of 0. It's not possible to divide by 0. So you say this is not possible. Undefined, not possible. That's the only thing it cannot be 0. And this one had 3. Same process. Do it 3 times. Remember though, one of the biggest mistakes I see, and it's difficult because I don't see it, is when you're doing this, you put your matrix in, say matrix A, you replace the first column, then you go to replace the second column, but you didn't change the first column back to the original. So if you don't do that, everything else is going to be wrong. And as a result, I don't see it, you don't see it, and you say, I don't know how I got this wrong. But by then, something else has been in your calculator, so none of us see it. So just be careful that you go back to the original matrix. Questions? Please, got this? Callie, does this make any sense to you? No. No. Okay. Yeah.
Can you throw out to the last one?
I will. Yep.
So in the first one we were doing the area, is the answer plus or minus? Or
No, the answer is always positive. Area is always positive. The plus or minus is there because if your determinant turns out to be a negative number, you use the negative 1/2.
Okay.
So it forces your area to become positive. Area always has to be positive.
Okay.
So we'll walk through this. I'll walk through it a little slower. Coefficients, constant. So you make your matrix. We're going to find the determinant, so we use bars. Now, what you want to do is take the determinant of your coefficient one. How we get a determinant is you plug in a matrix. I don't know if I have a matrix in here. Okay, I have a 3 by 3. This 3 by 3, it has to be a square. Okay, go to math. You're sitting right at the word determinant. Click on it. I'm going to just put in C because I don't know what's in there, but at least there's a 3 by 3. And this gives you the determinant. Whatever that determinant is, keep track of that. This is not the same thing that's in there, but at least I had something to show you. Okay, so now, we keep track of this major determinant. call it big V. Then find the x, y, and z. This is x, this is y, this is z, right? Take the column of x's and replace it with the constant. And find the determinant of this. Just change your matrix, say determinant, excuse me, this was a 0, and then you set up a ratio. And you find out what your value was for x. Then go back to your original matrix, take the constant, and substitute in for y. Find that determinant, set up your ratio. Go back to your original matrix again, substitute that in for z, and find that one. That gives us a solution. If our big determinant of our coefficients is 0, we can't do any of these because we can't divide by zeros. We can have a 0 in the numerator. It's just another way to solve for systems of equations. So we've learned REF, our REF inverses determinants. Okay. So you've seen a few variety of ways to do it. Was this the last one? Okay. Questions on any of these? On any of these?